opened one of those zip files and kind of wondered, like, how do they squish all that data down?
Mm.
What if I told you AI might have something to say about that?
Really?
Yeah, we're diving into some seriously cool research. This stuff links the way AI understands language to the way your computer compresses files.
It's a connection that surprised, honestly, even seasoned researchers in the field.
Right.
This paper we're going to be looking at today actually comes right out and says, language modeling is compression.
Bold statement.
Yeah.
It's like saying, like, writing a novel could help you fit more cat videos on your phone.
Right?
So how does an AI even start to compete with something? I mean, something purpose-built, like a zip file.
Okay, so that's where things get really interesting. It all boils down to this fascinating field called information theory. And at its core, it suggests that predicting what comes next in a sequence, whether it's letters in a sentence or pixels in an image, that actually lets you convey the same information using less data. It's all about recognizing and exploiting patterns.
So the better you are at predicting, the better you can compress.
Exactly. And that's where these large language models, these powerhouses behind things like ChatGPT, come in.
Okay.
They've gotten incredibly good at predicting what comes next in a sequence of text.
Right.
So the research team kind of wondered,
Yeah.
could this predictive power translate to other types of data, like
Mhm.
images or audio?
And what did they find? Did they just feed an AI a bunch of vacation photos and hope for the best?
Not quite. They focused on a particularly powerful language model called Chinchilla. And here's the real kicker. They didn't specifically train it on images or audio.
Oh, wow.
They used a technique called in-context learning.
Okay.
Essentially, they gave the model a tiny snippet of the image data,
Okay.
almost like a sneak peek,
Okay.
and let it run with it.
So like giving someone the first couple puzzle pieces and they just like go, oh, I know what this is. And they finish the whole puzzle.
Yeah, a bit like that. They basically challenged the AI to predict what should come next based on that initial context.
Wow.
And incredibly, it worked.
No way.
They discovered that Chinchilla, using this in-context learning, could actually compress certain images and audio better than standard compression methods,
What kind of standards are we talking about?
like PNG and FLAC.
Oh, hold on. Are you saying this AI casually outdid programs that were like specifically designed for this?
Yeah, just how much better are we talking?
In some cases, significantly better. For instance, they found, well,
Okay, so before we go any further and like crown AI the ultimate data crunching champ,
all right.
let's talk about the elephant in the room, or
Yeah.
maybe the massive server farm in the room.
Uh-huh.
These AI models are huge, right?
That's right. There's a really fascinating trade-off at play here.
Okay.
While larger models can theoretically squeeze out more efficiency,
Right.
they also come with this hefty size penalty, you know?
Right, it's like trying to pack light for a trip, but you bring your entire wardrobe just in case.
Yeah.
So at some point, the model's own size kind of negates any compression games. Like, it's like a
Yeah.
digital game of Tetris where the blocks are starting to stack up a bit too high. That is a very apt analogy.
Yeah.
And the research actually delves into this whole balancing act.
Okay.
They visualize this relationship between the AI model's size,
Okay.
the size of the data being compressed, and then the overall compression rate.
Mm-hmm.
What they found is that for any given data set,
Yeah.
there's a sweet spot,
Okay.
an optimal model size that strikes the best balance.
So it's not just about building bigger and bigger AI, it's about finding the right tool for the job.
Exactly.
Are there ways to make these models themselves more efficient, or are we stuck with this size problem?
That's where things get even more intriguing. So the researchers also explored something called tokenization.
Okay.
It's a fundamental concept in how these language models operate.
Okay.
Essentially, tokenization is how the AI breaks down text into smaller units.
Right, like chopping a sentence into individual words or even
Yeah.
like parts of words.
Precisely. And what they discovered is that tokenization in itself
Yeah.
is actually a form of compression. It's about representing the information in a more compact, efficient way. They experimented with different tokenization methods
Okay.
and found that it dramatically impacted that final compression rate,
Wow.
especially for smaller AI models.
So by cleverly choosing how we chop up the information at the start, we can make the whole compression process way more efficient from the get-go.
Exactly.
That's wild. It's like organizing your suitcase before you even try to zip it closed.
Exactly.
Oh,
And this insight opens up a whole new line of inquiry, right?
okay.
If we can optimize how we represent data at the most basic level
Okay.
through tokenization, we might unlock even more impressive compression capabilities,
Okay.
even with smaller, more
Yeah.
manageable AI models.
That's really incredible to think about.
Yeah.
But this whole idea of AI and compression, it's about more than just shrinking file sizes, right?
It is, yeah.
It feels like it hints at something deeper about how these models understand information in the first place.
Absolutely. And here's where it gets, in my opinion, really mind-bending.
Okay.
They took this concept of compression being linked to prediction, and they flipped it on its head.
Okay.
They asked, what if instead of using AI for compression, we could use a compressor as a rudimentary form of AI?
Wait, hold on. We're going from AI that can zip files to like
Yeah.
AI that can generate things.
You got it. So remember how a good predictive model
Mhm.
anticipates what comes next? They figured out a way to use a compressor's knowledge of data patterns to actually generate new data.
I'm not gonna lie, I'm a little lost. So how do you even start to turn a compressor into like an AI artist?
Yeah, so
What, did they feed it like a bunch of ones and zeros and say, make me a masterpiece?
it wasn't quite that simple,
Okay.
but you're getting the gist of it.
Okay.
So let's say they wanted to generate an image. Right?
Okay.
They'd feed the compressor some starting data,
Okay.
like the first few pixels,
Mm-hmm.
and then essentially ask it, based on your compression knowledge, what pixels are most likely to come next.
And it did it. It actually worked.
The results were fascinating, to say the least.
Okay, like what are we talking? Like vaguely Picasso or more like a toddler with crayons?
We'll be sure to include some of these AI-generated images in the show notes. They're not winning any art awards anytime soon,
Okay.
but you can actually make out some shapes and patterns.
So still early days, but it seems like proof that this connection between compression and creation has, real potential.
Definitely.
Are we talking about a future where my phone's file compressor is composing symphonies in its spare time?
Maybe not symphonies just yet,
Yeah.
but it does highlight this really profound connection
Okay.
between how we store information
Yeah.
and how we might eventually create truly intelligent systems.
This is all incredibly cool and exciting, but let's bring it back down to earth for a sec.
Yeah.
Why should someone listening to this, someone who maybe just wanted to know if AI could help them declutter their hard drive,
Right.
why should they care about any of this?
That's the heart of it, isn't it? This research isn't just about making zip files smaller.
Yeah.
It challenges us to rethink what AI can be.
Okay.
It suggests that maybe true artificial intelligence
Mm.
isn't just about raw processing power,
Okay.
but about understanding and representing information
Yeah.
in the most elegant, most efficient way possible.
So it's like saying the smartest AI might not be the one with the biggest brain, but the one who knows how to use its brain power the best.
Exactly. It's about finding elegance and efficiency in the way information is represented, manipulated.
Like the human brain, right?
Yeah.
It's not the biggest in the animal kingdom, but man, is it efficient.
Absolutely.
So where does this all lead? What does it mean for AI if we can really, truly make this super efficient representation happen?
Imagine AI that can learn from way less data than what current models require.
Okay.
AI that can adapt and personalize experiences in real time, but with a fraction of the computational resources.
AI that doesn't need to be spoon-fed mountains of data just to understand a simple concept.
Precisely. It could revolutionize everything, from personalized medicine to scientific discovery,
Wow.
all while being far less energy intensive and way more accessible to a wider range of developers and researchers.
That's incredible. We've talked a lot about the potential here, but I gotta imagine there are some challenges too, right? I mean, there's gotta be a ton we still don't know about how these models actually learn
Absolutely.
and represent information, on the inside.
This research is really just the tip of the iceberg.
Yeah.
It opens up this whole new avenue of exploration in understanding both AI and just the very nature of information itself.
It's pretty wild to think that we're still in the early days of AI.
I know, right?
Who knows what's out there, what we could discover as we unravel all these mysteries.
Absolutely.
Well, that brings us to one final thought I want to leave you with today.
Okay.
If compressing information is this closely linked to actually understanding it, I mean, what does that really mean for the future of AI? Could these really smart systems one day anticipate our needs, even predict our actions,
Yeah.
understand the world around us in ways that, honestly, we're only just starting to imagine?
It's a question that really pushes the boundaries of what we think is possible.
For sure.
This journey into like the heart of AI,
Yeah.
it's just beginning. And as we've kind of seen today, it's full of these unexpected connections and honestly, mind-blowing possibilities.
A huge thank you to you for taking us on this incredible deep dive
Oh, it's my pleasure.
into this amazing intersection of AI and compression.
Always a fascinating topic to explore.
And to you, our listener, thank you so much for joining us on the deep dive. Until next time, keep exploring, keep questioning, and most importantly, keep that curiosity burning bright.